In this video, you will see an example of comparing standard deviations without calculations. Three distributions labeled A, B, and C are represented below by their histograms. Each distribution is symmetrical and is made of 10 measurements. Without performing any calculations, order the respective standard deviations sigma sub A, sigma sub B, and sigma sub C. It is important to note that these distributions are symmetric and at the center of the data is the mean. So our mean in all three cases is at 6. Remember that the closer data elements are to the mean, the smaller the standard deviation is. So when you look at these three histograms, I hope you agree that histogram A shows me data that is tightly close to the mean of 6. So this data set seems to have the smallest standard deviation. Now, if I compare this data set A to data set B, I notice that element that used to be at 4 moved and shifted to 3. In other words, this box right here moved down to 3 and this box moved down to 9. This change gives you a wider spread of data away from the mean of 6. So compared to standard deviation sigma sub A, standard deviation sigma sub B is bigger. So far I can conclude the following, that sigma sub A is smaller than sigma sub B. What can I tell now about standard deviation for distribution C? Let's compare its histogram to the previous histogram in distribution B. Please look at the picture. So far I can see that the lower three items at 3, 4, 5, and 7, 8, 9 seem identical. I had a higher peak right here. I had an extra element 5, an extra element 7, which were close to mean of 6. But in this histogram from distribution C, they moved from 5 to 4, or they moved farther away from the mean here on this side and from 7 to 8 on this side. So my standard deviation has increased even more because I have 2 more elements that used to be closer to the mean, now they're farther away from the mean. So I can conclude one more time that standard deviation of distribution C happens to be the biggest. This is my conclusion. Please remember that the farther away your elements are from the mean, the bigger the standard deviation will get.